Hi, I'm Kaden, and I'm here to talk about the sliding filament theory. Behind me is Mr. Muscle Man, and he obviously needs to know how to contract his muscles. So the sliding filament theory comes into play with the two filaments called myosin and actin. They will slide across each other in order to contract, and which will help us understand how to contract a muscle. Which brings us to tendons. Tendons will attach to muscles, and these muscles will be on the macro scale endomysium or epimysium, paramysium, endomysium, and then we reach to the muscle cell. And this muscle cell can be further broken up into a myofibril. A myofibril will then have even a smaller unit of sarcomeres. However, before we go on to there, here's an important thing we need to know. The sacral plasmic reticulum is wrapped around all this myofibrils, and it acts as a way to transport all the important molecules and nutrients this muscle cell needs, and specifically the myofibril. In here we could see T-tubules, which will come into play later, which next will bring me to the brain. The brain will obviously need to act as a how to start these contractions, as we know where they are, and they happen on a myofibril down to the muscle cell. And so the brain will send a signal via a neuron, and it'll send it all the way down to our whatever muscle it is. And so thousands of neurons, as you can see, can pass through Mr. Muscle Man in order to get to the one location that we need and the one muscle cell we need. So the brain passes it to the neuron. The neuron will happen at the synapse, will have a wave of depolarization ions acting as a way to send a signal. And the signal is what? Well, to contract a muscle, we need adenosine. Adenosine will act as a pretty much the specifying thing and neurotransmitter we are trying to send to the muscle. Hey, we need to contract our muscle. And so through the T-tubules, as we can see here and here, it'll pass this adenosine. But with it, these vesicles will, as the vesicles pass adenosine, they will also open up calcium to transport through. Calcium will be important as it'll allow myosin and actin to actually bind and form a cross bridge, which brings me to my next slide. A sarcomere is one of the smallest units we can split a myofibril into, and it'll be identified by the Z lines here and here, and they will get shorter as contraction happens, as myosin and actin crawl against each other. And then we could see that also there's an M line identifying the middle and kind of where myosin attaches to it in order to shorten the length of the Z line. So yeah, which brings me to the next slide. Actin will act as a binding site for myosin to crawl up on, and so to clearly demonstrate this, we will go to the next slide. And so with this, we are able to perform a power stroke. How? Well, that calcium, as we mentioned earlier, will play an important role in tropomyosin. It is the wrapping around of actin and acts as a barrier for myosin to actually bind to actin. And so once that happens, ATP and ADP will play an important part when the myosin head is trying to bind to the actin, which is called the actin site, actin binding site. So the important part of this is calcium will act as a key to our lock of troponin, which will then unlock the tropomyosin to allow myosin to attach to actin. So with this, on step one, we can identify that ADP and phosphorus will be binded to the myosin head and be able to cock the myosin head into position. And then on step two, we can see how this phosphate will leave and get out of here because it's using its energy from prior steps, as this is repetitive. onto the myosin head, allowing the ADP with the myosin head to attach to the actin site, actin binding site, which then ADP leaves, and we're left with step 3, as you can see on the bottom. It will be binded to the myosin and acts as a power stroke in order to move and contract and shorten the muscles on a very micro scale. We can see how this small little movement will build up after thousands and thousands and thousands, etc. Will do this power stroke, which leads me to step number 4, which is ATP. In order to repeat this process and continually pull as much as our muscles are shortening, we need to detach them and replenish them with more and more energy. The important energy here is binded between the second and third phosphate in ATP, as ATP stands for adenosine triphosphate. Tri being 3 has 3 phosphates. The energy binded between them will be released as we go back to step 1 and repeat this whole process and allow our myosin to crawl pretty much on all this actin and allow us to shorten the muscle. Same thing with relaxing. It'll go the opposite way and more energy will be used. And this, as it has finished its cross bridge, will either detach, or depending on where we are left off in these steps, we will be kind of done. So that leaves me with nothing. Thank you. I'm Kaden, sliding filament theory. Now Muscle Man knows how to contract his muscles.